Hi, you're watching Floyd Steinberg's YouTube channel. Today, let's take a look at the Tulip musical computer, which in fact is much more than a musical computer. It's a great open source educational project. And if you think that's interesting, please join me in this video. Here we go.
Tulip is a project by Brian Whitman, who also built the ALS mesh networking synth I made a video on last year. I have the official hardware here, but there's no need to buy this. You can build this yourself using a breadboard and an ESP32S3 Vroom 1 and 32R8 development board. Well, that's a mouthful. In fact, you can also just download the software to your computer and start using it without any additional hardware at all. The official hardware is mainly touchscreen. This is a 7-inch IPS panel. There's a power switch, MIDI, TRS, in and out, a USB Type-C power socket and keyboard connector, a reset switch and an I2C interface. There's a protective plate on the back, and there's enough space between the plate and the screen to install a rechargeable battery. The computer can be connected to your Wi-Fi network, but it didn't recognize a USB hub when I tried, so there's not a lot of peripherals you can use simultaneously. Right, now before we start, it's time for this.
Get down, baby, get down. Right on, get down.
The Tulip is a computer running the programming language Micropython instead of a graphical operating system, just like 1980s home computers ran BASIC. As a musician, you can just start by connecting a MIDI keyboard to the computer and play the built-in Juno 6 emulator. There's also a TR-808 style drum sequencer available. Just press the menu button in the bottom right corner to use it. Using the Voices widget, you can also switch to a DX7 emulator to complete the 80s home studio setup. This in itself is quite useful already, but let's take a look at the broader picture. The synth emulations are based on the Tulip's synthesizer framework called Amy, which is a 120 oscillator software synth that provides developers with an array of functions. As I already said, Tulip's main user interface is Micropython. Using that language, you can utilize graphics, the touchscreen, network, MIDI, the sound system, and the sequencer. I want to focus on the musical functions here. On Tulip, there's a sequencer running continuously once you boot the system. This sequencer can trigger Python code if certain criteria you defined are met. There's a very simple example in the manual which demonstrates this. We can make the sequencer play random notes with just 6 lines of Python code. First, we import the libraries we need for this code. Then we pick a chord from the music library. Then we pick one of the software synths running depending on the system. Next, we define a function named note that sends a note on command with a random note from the chord we picked previously with a velocity of 0.6 and a time t. Next, we'll add a sequencer callback event listener that will cause the sequencer to run a note function at every 48 ticks, which represents a quarter note. Let's try something with more real-world application next, a keyboard split. We start by importing all the libraries needed. And next, we need to define two synthesizers, synth 1 and 2. We will assign two different patches to them, a bass sound and a pad sound. Next, we'll suppress the default MIDI event handler and add our own event handler. In this function, there are two if clauses. The first one triggers when a note on MIDI code 144 is received. The second one when the note off MIDI code 128 is received. We will then also evaluate the note number. Once it's 60 or higher, we will play the note on synth 2, otherwise on synth 1. Same goes for the note off command. I'll also add and subtract 12 to shift the notes up or down by an octave, so there's a 2-octave gap between the left and the right hand on my small keyboard. And after fixing some syntax mistakes, here's the result. While that's certainly useful, I'd like the Tulip to be a bit more active here. How about automatically playing eighth notes on the bass? I also want to send the right hand to an external synthesizer, my Yamaha EX5 keyboard. This is, like in the very first example, achieved by letting the sequencer trigger notes, but only when I press a key on the MIDI keyboard. Here's how that sounds. That's not bad, but a bit boring. Let's add a random element to that bass. Only 50% of the notes will be played and 25% of the notes will be transposed an octave up. The right hand is still routed to the Yamaha EX5 and there's also a drum pattern playing along. I could go on talking forever and ever on the Tulip, for example its sample player, the graphics capabilities, or the built-in bulletin board named Tulip World where you can share your ideas and your code. But I think I'll end it here and leave that up for you to discover. As always, all the links are in this video's description and it's easy enough to download the Tulip desktop app and get started. Regarding the hardware, my impression is that it's solidly built, but the CPU sometimes seems to struggle to keep up with what's going on. There have been some significant improvements with the last firmware updates already, so perhaps this criticism already is moot once this video is online.
Yeah, and that's it for today. Tulip, an open source DIY music computer, and if you think that was interesting, please visit Brian Whitman's page, which is linked in this video's description. And if you think this was a good YouTube video, please do the YouTube thing. And if you want to support this channel financially, you can join my Patreon, buy my music on Bandcamp, become a member of this channel using the button under this video, or listen to my music on Spotify or Apple Music. As always, thanks for watching, and see you again very, very soon. Bye bye!